The last application I wanted to show you, and we did it internally, was the AI or machine learning, should I say, based prediction of mechanical properties and gelation kinetics of hydrogels. I believe that AI and machine learning are opening a lot of opportunities, of course, but in the context of biomaterials, we tried to see or evaluate the feasibility of predicting the mechanical properties of hydrogels by developing a model and testing the model. So the project was based on first building a database of experimental kinetics. So we used PIGDA for this study, and we built the model based on three parameters: the concentration of the monomer, the light intensity, and of course time, to predict over time the kinetics of gelation, photo cross-linking of the PIGDA. So we started by building a database. In this case, I think we used almost 120 kinetics, experimentally generated kinetics. We used almost 100 to train the model, and the remaining 20 kinetics were used to validate actually the model. So we built first the database, we trained the machine learning model, we validated the model, and we ended up by having a quite efficient model able to predict the gelation kinetics of PIGDA. So you can see here in this graph how the model is behaving. So by simply introducing on the code the PIGDA concentration, the light intensity we desire to use, and the time. I'm interested on the kinetics over 30 minutes or 20 minutes or more than that. And the model actually is able to predict the gelation kinetics. So you can see here in this example, three different concentrations of PIGDA and the comparison between the measured actually kinetics and the predicted ones. So it was quite nice to see how the prediction was close and very consistent.